As we already discussed, we should not create a pod directly, as pod is ephemeral and it is not getting rescheduled if it is not running. So we have to create with the help of controllers like replication controller, replica set. We have these objects, replication controller, replica sets, deployments like stateful sets. These are going to manage the pods. We have a pod, we have service, right? Pod is the smallest building block which we can deploy in Kubernetes. Pod represents running process. Pod contains one or more containers. These containers will have share same network storage specifications. Pod will have unique IP in Kubernetes cluster. So this is what pod, right? As we already discussed, we should not create pods directly. We should not create pods directly. If pod is down, it won't be rescheduled. For deploying applications, right? So if pod is down, we should not create, it will not reschedule, right? So pod will have a unique IP address. Pod will have a unique IP address in Kubernetes cluster. So we should not create pod directly for deploying the applications. We have to create pods with the help of controllers which manages pod life cycle. So this is what we have to do. These are the controllers which can manage the pods. And what is service? What is service? We discussed service is for a communication. Service will make our pod accessible are discoverable within the cluster or exposing them to the internet, basically outside the cluster. So service will identify pods based on label and selector. So we created already service. What type of service we created? So far, like cluster IP and node port. Within the cluster, outside the cluster, we can access. So this is what we have discussed so far. So we should not create a pods directly. We have to create with the help of controllers. And pods, there are like single container pods, multi-container pods. We have these types of pods. What is single container pod? Like pod will have only one container. So most of the time your pod will have only one container, right? So what is multi-container pods? There are different types of pods like single container pod, multi-container pods, right? Most often, like most frequently, when we deploy a pod into a Kubernetes cluster, it will contain a single container. Most of the pods will have only one container, but there are some cases, but there are some requirements, we may need to deploy multiple containers in the pod. Multi-container pod, or sometimes we call this one as a sidecar containers. Sidecar. One container will help other container. You have some requirements, like you will have some in some cases we may have special requirement, like to achieve some functionality, there will be two containers. Both will work together to complete some functionality. Single container pod, multi-container pod, or sidecar containers. We call it as a sidecar containers. So in this single container pod, we will have only one container. The way we created, we created some pods. So these pods are what? Single container pods or multi-container pods? If you see what is this, right? Single container pods. So some scenarios, right? This is the common use case. Most often we will use single container pods. In some scenarios, you will have like, our pod will have a multiple co-located containers. Like two containers together in the same pod. Wherever you create that pod, you will get those two containers. Multi-container. So a primary container and utility container, like it's kind of a helper. It's kind of a helper. You will have your primary container, there will be a helper for that, which will help to achieve some functionality. Utility container, if you take this example, right? This is the pod. This is the pod. And this is your primary container. So for this primary container, suppose it is continuously looking for some files. Like it is trying, we have a requirement like this container has to read the files from outside. And it will serve the files. It will serve the files. So instead of coding everything in same container, there will be a like scenario. There will be another container which will read the files from outside, and which will make available those files to this container in the value. This is multi-container pod. This is the primary container. There will be a helper. There will be a helper container. We call it as a sidecar. Sidecar, helper. You have some kind of requirements. In that case, you will have a multiple containers in the same pod. So if it is running in the same pod, what pods will share? What containers will share if they are in the same pod? What is common for containers which are there in the same pod, guys? If two containers are there in the same pod, what is common for both? Network as well as storage, basically volumes. So we call it as a sidecar. Sidecar in the sense helper container. Network and storage is common for this pod. If these two containers are running in a same pod, so this can access the storage, this can also access the storage, basically your value. So this can read something and update in the volume, so this can use that. It's kind of a helper, primary container and utility container, helper container. Multi-container pod or sidecar containers. So this is common and very important question, as I asked last week itself. How one container can communicate with other container within the pod. I mean to say, if both are in same pod, how it will communicate with each other. As I discussed, do they need IP? Since they are sharing in a same network, so all the containers in the pod share the same network, which means all containers can communicate with each other on a local host if they are in a same network. If you same pod, if you see, this container can access this container using local host and its port. So this is how pod will work. Now, whatever pod, whether it's a single container pod or multi-container pod, we should not create a pods directly. We should not create a pod directly. So we have to create with the help of controllers like this. So and before I go for a before I go for a controllers, there is a one more type of pods. Recently in one of interview for our student, they asked this question: what is static pods? There is a concept called static pods. Okay, so what is static pod? This is one question recently for our student asked this question: static pods. Static pods. What is static pod? So static pods are directly managed by the kubelet. Basically, what is the heart of Kubernetes architecture? Like, which component is most important? The API server, right? The API server. So there is a concept called static pods. Static pods are managed directly by the kubelet, and the API server does not have any control. The API server does not have the any control over these pods. Static pods are managed directly by the kubelet, and the API server does not have any control over these pods. The kubelet is responsible to watch each static pod, and it will restart if it crashes. It will restart if it crashes. The static pods running on a node are visible in the API server but cannot be controlled. So if you see, we already have some static pods. If you see, we already have a static pods. For this one, for etcd, Kube API server, control manager, and scheduler, these four. If you see these four: API server, control manager, scheduler, and etcd. So these are static pods. These are static pods. How can I say these are static pods? If you see, who is managing these pods? If this goes down, suppose control manager is deleted, gone. Due to some reason, control manager is gone. Due to some reason, scheduler is gone. We cannot delete, but let me see, kubectl delete. I am trying to delete this. In the kube system namespace. Now, which one I deleted? I deleted scheduler. But do you see again? It is immediately coming. So who is managing these parts? Who is creating, who is managing these parts? If you see, do I have a controller? If you see, we discussed about few controllers. Do we have any controller who is managing these pods? If you see here, for kube DNS, for kube proxy, there is a controller. For kube proxy, there is a controller here. For ViewNet, there is a controller. For core DNS, there is a controller. But do we have any controllers for these pods, these four pods? Who is managing these pods? These pods are directly managed by the kubelet, which is running on that node. So static pods are managed directly by kubelet, and the API server does not have any control on these pods. The kubelet is responsible to watch each static pod and restart if it crashes. These static pods are visible to the API server but not be controlled by the API server. Static pods does not have any associated controllers. Kubelet itself watches and it will restart. So the main use of static pods is to run self-hosted control planes. Like, we have a API server, scheduler, etcd, right? These are static pods. So what is kubelet? What is kubelet? No, it happens in the master also. Now these are where running, no, these pods are running in where? The scheduler pod, API server, control manager. Where are these pods? These pods are running on the workers? Master. Master, right? So you can create a static pods in the master as well as in the workers also. So kubelet, don't get confused. Kubelet is not a CLI. Kubelet is not a CLI. kubectl is a CLI. Kubelet is a process or agent. Kubelet is in master node as well as in the worker node. Kubelet is in the master node as well as in the worker node. But kubelet, like master machine, will use kubelet as an agent. Master machine will use kubelet as an agent, right? So these are the static pods. So if I want to create a static pods, suppose if I have a requirement, we will not do that. So where should we create a how should we create a static pods basically, right? If you want to create static pods, you have to place your YMLs in some folder. So if you see, there is a folder here. If you want to create a static pods in some system, if I want to create a static pods in some system, where should I keep my YML so that static pod will be created? If I want to create a static pod in the master, I have to place that pod manifest in this folder. So in this folder. Now if you see, do I have a folders? Do I have a YMLs here? Control manager, API server, etcd. So this is the manifest file. Pod, right? Image name. What is the image name? If you see, who is managing this image? So who is managing this image? API server also created as an image, right? This is owned by Kubernetes. So if I want to create my own static pod, where should I create? Where can I place my YML so that it will be created in this folder? Let me show you. First, let me delete this one. This is normal pod which we created. This is normal pod which we created. Now, so this is my YML, right? To create a pod, if I create this YML, if I create this YML in that folder, if I create that YML in that folder, right, I will get a static pod. So just I'm creating something like this. The moment I save this file, now let me see. So now who is creating this one? The kubelet, right? Now this is monitored by kubelet. If something goes wrong with this pod, kubectl delete pod. Now, if you see, again I am getting this pod. Again I am getting this pod. But who is creating this pod? I don't have any controller. Did I created a pod with the help of these controllers? That pod? No. So that is directly managed by kubelet because I have created a static pod. So this is in recently in one of interview, it has been asked. So I thought of adding that one also. So static pods. This is directly managed by the kubelet. So we will not go for a static pod phase, right? We will use controllers, right? If you want to have some pod which is managed by kubelet irrespective of the controller, then you can go for a static pod. But we will not go for a static pod. Our application will be deployed as a controllers. So API server will monitor. Basically, API server will manage with the help of these controllers. So that is what a static pod. Now in Kubernetes, before I go for a controllers, these controllers, first we will understand labels and selectors. We are already using labels and selectors. We are already using labels and selectors. If you see, we are already using labels and selectors. If you see, this pod has this label. If required, we can have a more labels. You can attach more labels also. You can attach more labels if you require, like something like this. Just your application, just to give something like this. Let me apply that. So we can have a more label, something like this. So there is no direct command to identify the static pods, right? You can just check whatever is there in that YML, that folder, those will be running as a static pods, and you will not see any controllers for those pods like the deployment, daemon set or replica set, replication controller. You don't see any controllers for those pods. So this is one pod. Pod has a label. You can have one or more labels. So when we are creating a pods, we are giving a labels. We are giving a labels. What is the purpose of labels, right? If some other object has to identify this object, labels are very important. If one object has to identify other object, labels are very important. So if you see, now this pod doesn't have any label. Now will service will able to identify this one? Now I have not given labels while creating a pod. Now there is a service. There is a service. Now will my service will able to identify? Now let me show, will it able, will I able to access inside? And will I able to access outside? So this is the public IP address of this server. Three 0106. So why it is not working? Even though I have a service, even though I have a pod, why it is not working? Because how service is trying to identify the pod? How service is trying to identify the pod? If you see here, selector. So in the selector, what I have given? This one. What is this? Basically, it's a label. It is looking for an object which is having this label, which is looking for a pods which is having this label. Labels are very, very important. Now I don't have a pod. I don't have a pod with that label. If you see, so none of the pod has this label. So now let me edit my pod. I can give like this app, Java, web app. If required, you can give n number of things, something like this. Just key value pair. Now if you see pod, pod has these labels, and service. Service I have just given this one. But even though pod has two, but at least in the service I have given one. Will it match with this pod? Even though pod has two, here I have given only one label. Does it match with this one? Now, if you see, you just describe the service, you can understand. kubectl describe svc, your service name, whatever you created. Now, do I see the endpoint? Now it is able to identify this because of this labels and selector. Now I can access outside. I can access inside also. So labels and selectors. What is the use of labels and selectors? When one thing is nothing but when one object in Kubernetes needs to find another object, it will use labels. It will use labels. Labels are key value pairs. Labels are key value pairs. Labels are key value pairs attached to an object. It's a key value pair. You can give your own key and your own value. You can give your own key and you can apply it. Something like this, labels, key, value, key, value. You can give n number of labels. Like, it's like a tags. You are tagging your Kubernetes object with some key value pair. So selectors. There is another thing called selectors. Selectors are like a conditions or filters. Selector uses label key to find a collection of objects matched with same value. It's like a filter or condition and query your labels, something like the selector. So we will use these labels and selectors in the services, in the controllers like replication controller, replica set, daemon set, deployment. So this is how we can use labels and selectors. So service will identify the pods. Yeah, key also you can give anything that is in our own control, right? If you see, I can give anything. I can give ABC, XYZ, something like this. Any key, any value, label, key and value. If you want to find these objects from some other objects, you have to use this as a selector. This as a selector. So you can give your own key and value. Like it is like you are tagging this object with some key value pair. So other objects can find these objects with the help of selectors. So now we have given a label to the pod and this we are using as a selector in the service. If you see here, we are using this selector. So service is identifying the pods based on the label. For service also you can give a labels, but it is not required. For service also you can give a labels. For service also you can give a labels. If this service has to be found by some other object, we can use these labels. But this is not mandatory because service we are not trying to find from any other object. So any Kubernetes object which we are going to create, you can give a labels. If some other object has to find that, we can use that label as a selector. So now let's come back to the controllers. We already discussed about service. We discussed about cluster IP and node port. I'll come to this load balancer. We cannot create a load balancer service now. Label is you are tagging with something. Label is you are tagging with some key and value. And how can I find that object from some other object? I created a pod with some labels, and I am trying to create a service my pod, service for my pods or controllers for my pods. What is the use of service? Service will try to find the pods and it will route the traffic. How service is able to find the pods? What concept it is using internally? How I am, service is trying to find the pods with the help of what? Kube proxy is for a network routing. Now I created a pod. I have a pod. I have a service. I have a pod. I have a service. How this service is identifying the pods, to which pods it has to route the traffic? Pod is having what? Pod is having what? Labels. And while creating a service, what I have given? Selector. So this service is trying to identify the pods with the help of what? Labels and selector. Suppose I have given a wrong selector, even though key is same. Now I have a pod, I have a service. Now will it work? Is it able to? Why I am getting connection refused? Selector is condition. Let's take this as an example. You have a table. Let's take this as an example. You have a MySQL table. You have a MySQL table, right? And you have a lot of records. How do you find the records? Matching. You will use conditions, right? Selector is like a condition. So selector is like a condition or filter. It will try to find whatever objects which is having the label which you have given. You are trying to find something, right? So we are filtering. This is trying to find something. We are giving that as a selector. Selector is like a condition or query which will try to query the matching key value pairs which you have given as a selector. So we will use selectors in the services and controllers, right? So how controller will manage the pods again? Controllers will use pod labels. Controller will use again pod labels. You have a pod with some label. Controller will use those pod labels as a selectors. So it will try to control those pods by filtering with the help of labels. So again, let me edit this service. Let me apply again. This is like a condition. You are querying This object is trying to find some objects. Whatever object has this label. So it's working. So now let's come back to controllers. I will come to this load balancer. It will not work. We cannot create a load balancer service in this cluster. I'll come to this later. First, let's understand this. What is this controllers? As we already discussed, we should not create a pods directly. As we already discussed, we should not create a pods directly. We cannot scale the pods. And if pod goes down, it is not getting rescheduled. So we have to create a controllers so that the controllers will create a pod and it will manage the pod life cycle. We have these controllers like replication controller, replica set, deployment, and there is a one more daemon set. So these are controllers. We have to create a pods with the help of these controllers so that the pods will be managed by these controllers. So we have a replication controller. First, let me start with replication controller, then we will understand the others. Replication controller is one of the key features of Kubernetes. So replication controller is one of the key features of Kubernetes, which is responsible for managing the pod lifecycle. Replication controller is responsible for managing the pod lifecycle. And what it does? And it is also responsible for it will make sure that specified number of pod replicas are always running at any point of time. It will manage the pod life cycle and it will also make sure that you have the specified number of pod replicas are running at any point of time. So with the help of replication controller, you can easily create multiple pods. We can easily create multiple pods. Then it will make sure that pod always exists. If pod is gone, what replication controller will do? If pod is gone, replication controller will recreate. It will recreate. It will recreate. Now replication controller and pods are associated with again labels. So how it will find whether it is running or not? It will try to query with the help of labels and selectors. So this is like one manifest file to create a replication controller. If you see, I am trying to create a replication controller. And here, I am saying how many replicas I need, how many pods I need. I said 2 pods. And where is my pod information? This is my pod information. This is my pod information. So now if I create something like this, if I create this object, how many pods will be created? If I apply this YML, how many pods will be created? 2 pods. 2 pods from which we will get a 2 pods, and each pod will have how many containers as per this manifest? I will get a 2 pods, and each pod will have how many containers? Each pod will have how many containers as per this manifest? How many containers? One container from this image. So we are creating a pods. This is my pod information now. Here I have a pod information. Under this, we are giving again name, label, spec. This is my pod information. So replication controller will use this information to create a pods. And how many pods it will create? That is based on the number of replicas we are mentioning here. Once these pods are created, it will manage those pods with the help of this label. Your pod has a label, and while creating a replication controller, you are giving it as a selector. So these pods will be managed by replication controller. Now, if I have a service with this as a selector, now service will have how many pods? Suppose if I have a service with this selector, I have created a service with this selector. Now our service will have how many endpoints? If I create a service, and while creating a service, I have given this as a selector. Now our service will have how many endpoints? 2. So now, if service has a 2 endpoints, it will act as a load balancer. So we have to create a replication controller. Basically, we have to create a pods with the help of controllers. Something like this. Kubernetes manifest, API version, kind, metadata, spec. As per the given table, what is the API version for replication controller? V1. Kind. Kind is what? What kind of Kubernetes object I want to create now? Replication controller. API version, kind. What kind of object you want to create? Replication controller. Metadata. Name. This name is for what, guys? Is this name is for our pod, or is this name is for this replication controller? This name is basically for replication controller name. Now here also I can give a labels, but it is not mandatory. But these labels are for what, guys? Here also I can give a labels. Here also I can give a labels. These labels are for what? Here also I can give a labels, but it is not mandatory. Optionally, we can give labels for controller also. But we are not referring this one anywhere, so it is not required. We can give labels for controller. It's optional. It's optional. I am creating a controller, right? So these labels are for your controller. Service will try to find the pods, not the controller. Service will try to find the pods, not the controller. I am creating a controller now. While creating a controller, I can give a controller name. I can give a labels. So if I create a service, service will try to find the pods, not the controller. So this is optional. It is not mandatory because these labels we are not referring in any other object. It is optional. I'm trying to create a replication controller. This is the replication controller name. And where should I define my pod information now? Under spec, I can say something like this: replicas, number of replicas. Here I am giving selector. Selector is for what? Not service selector, guys. Selectors we will use in multiple places. So we are creating a selector for, we are giving a selector for replication controller. So why it is required? What is the problem if I don't give? I can directly provide a template, my pod information. This is basically pod template. I can give something like this. Again, under this, we have a metadata. Again, under this, we have a spec. This we call it as a pod template. This we call it as a pod template. What information we are defining under this? So name, your pod name. Here we are going to give a labels. What is this labels? Your pod labels. Key value. These labels are for pod labels. Under spec, what we have? This is basically pod template, right? We will have a containers, name, container name, image, your image name, ports, all your container related information. Now we are trying to create a replication controller. Once the replication controller is in place, what is the job of replication controller? What is the job of? Try to understand the concept. Replication controller is for what? What is the job of replication controller? Basically, what is the job of controllers? It will manage the pods. Now, to maintain the state of your pod, to manage the pods. Pod is what? Pod is what? Pod is basically a set of containers. Pod represents the process. So, service is for what? Service is for communication. Service is for communication. So, service will try to talk to the controller, or it will try to route the traffic to the pod or container. It will try to talk to the pod, right? So What is controller job? Controller job is not for a communication. What is the job of the controller? It will make sure you have enough number of pods. And what is the job of service? The service job is for identifying the pods to communicate. So now you tell me, are we going to create a service for pods, or are we going to create a service for controllers? Pods, right? Controller will do its job, service will do its job, pod will do its job. It's like a shared responsibility. So now I am trying to create a controller. Now controller has to manage your pods. Once the controller is created, how controller will manage the pods, how it can identify whether pods are running or not. Again, how it can filter whether I have a pods or not. Again, it has to use labels. I have given a labels for my pod. Those labels, here I am giving it as a selector. Those labels, here we are giving it as a selector. Your pod labels as a selector. So this replication controller will try to find the pods based on this. If it doesn't find whatever is expected, it will replicate. So this is how we need to create a controller. We are creating a controller so that pods will be managed by controller. And service is for a communication. So now I should not create a pod directly something like this. We should not create a pods something like this. It will not be managed by Kubernetes. You should not create something like this. So this is not managed by anyone. So let me delete this one. We should not create something like this directly. Now if I want to create a pod, if I want to create a pod, this I have to create with the help of replication controller. So let me create something like this. API version v1 kind replication controller metadata name. I can say some name Java web app RC replication controller spec replicas. Guys, if I don't give replicas, how many replicas it will create? There is no scenario which you have to create a pod directly. Since I am explaining the class, since I am explaining the Kubernetes objects, I am explaining from like ABCD. If I go directly for a sentences, you cannot understand, right? So what is the problem with pod? You already know the problem with the pod. What is the problem with the pod? If container goes down, container will come up. But if pod is crashed, do you get a pod automatically? So you know that you will not get a pod. So do you go to the pod directly? So since I am explaining the Kubernetes objects, I am trying to explain all the concept. What is the problem? Then why we are going for replication controller. And what is the problem with replication controller? Then I will go for another one. Right? So since we are learning, I am trying to explain from the basics. Right? Based on the requirement, you can apply any of these concepts. So now let me give this selector. This is mandatory. If you don't give a selector, it will not work. If I don't mention this, guys, replicas, something like this, how many replicas it will create? If I don't mention this, it will create only one replica. If I don't mention replicas, it will create only one replica. Now, this is where I will define my information. What information? I will define my pod information. Metadata. Guys, this metadata is for what? This metadata is for your controller. And this metadata, here, whatever I am giving, under template, this is your pod template. Something like this. Your pod name, anyhow, this will not be used. Labels. For pod, labels are important. I can give some label, something like this. Spec. Guys, this is also spec. Here also you have a spec. But try to understand, this is spec is basically specification for your replication controller. This spec is basically for your pod template, right? So pod specification, what we will have here? Pod will have what? Pod will have containers, name, from which image you want to create. I want to create from so and so image. Guys, yesterday I think a lot of people posted one issue, image pull backup. Suppose if I give some image, if I don't give a tag or version, which one it will take, guys? If I don't give a tag here like version 1, 2, 3, if I don't give, which one it will take? It will take colon latest. Suppose if your repository, if your image repository doesn't have this one, will it able to create a container? Suppose let me show this. Now this is the image which I am trying to use. Where is that? Java-web-app. Suppose my repository doesn't have this one. If my repository doesn't have this one, I will get an error. Because image is not found, we will get an image pull back of error. Image pull back of error. So what this is representing? What this is representing, guys? I think in Docker we discussed, right? What this is representing? This is my repository name. Since I am using Docker Hub public repository, so this is my public repository Docker Hub repository name or username. And if when you are practicing, try to use your repository name. So if I don't give also, it will take colon latest. If I want to deploy this one, I can use version 1. If that is not there in my repository, I will get a error. Suppose if I give something which is not there. Suppose if I give 20 version, if this is not there, we will get a error. Image and ports, container port 8080. Guys, now I am creating a replication controller, right? If you see, this is my pod template, pod information. If required, I can mention the number of replicas, how many replicas I need. 2 replicas, 3 replicas, you can mention how many replicas you need. Now, if I try to apply, I will get some issue. Let me show that. Let me do the dry run. Now, here for replication controller, if I have not given selector, right? If I have not given selector, there will be a concept called hashing. It will use some hashing concept. It will use some hashing concept. Let me show that. I have not given selector. It will use some hashing concept. Let me show that. Now let me directly create. Guys, single hyphen we will use for short options. There is a long option like full name. So if I want to use something like this, hyphen, right? Something like this. Short names you can use single hyphen, long names you can use double hyphen, something like this. Guys, don't focus too much on the installation and commands. You can install by googling, you can find commands, you can find some cheat sheet, but try to understand the concept is very important. So now let me create replication controller. Now what is this? kubectl get replication controller, RC, in the short form RC, in the long form replication controller. So what is this? What is this desired, current, ready? What is these 3? This is one replication controller. So this replication controller, what it is managing? Replication controller is managing what? Replication controller is managing pods. So desired, what is the meaning of desired? How many we are expecting? How many we are expecting? How many we expected? How many parts we expected for this replication controller? 3. Current in the sense how many pods are there? Currently, there are 3 pods. Ready. What is the meaning of ready? How many pods are ready? How many pods are ready? By this time, all the pods will be ready. Currently, there are 3 pods and all the pods are ready. What is meaning of ready? It is ready to serve the traffic. It is up and running. Now, if you see, I created a pods, right? Pod has a label. Pod has a label. If I describe more information, kubectl describe pod, you can see more information about the pod. You can see more information about the pod. This is pod name, start date, label, and controlled by. What is the meaning of controlled by? Who is controlling this pod? That replication controller. If I describe RC also, I can describe RC, replication controller. I am describing the replication controller. So you can see replication controller information. So this is the part template it is using. So for replication controller, this selector is optional. It will manage. But when we go for a replica set, the latest version of replications, the selector is mandatory. This selector is mandatory. For replication controller, it is not mandatory. But when I go for a replica set, if I create replica set, this is mandatory. Without this, it will not allow us to create. Now I have a 3 replicas. Guys, I already have a service. I already have a service. I created a service already. Yesterday only we created a service. Now why service is having 3 endpoints? Why service is having 3 endpoints? Because I have 3 replicas. But total I have 4 pods, right? Total I have 4 pods, right? But why this service is having only 3 replicas? I have 4 pods. I have 4 pods, but why service is having 3 endpoints only? That is nothing to do with RC, right? That is nothing to do with RC. How service will identify the pods? That is nothing to do with RC. How service will identify the pods? Based on the pod label and selector. So now how many pods has this label which I have given as a selector in the service? Three. So now service will act as a load balancer. Internally, if I access with this, request goes to one of the pod. From outside also, if I access, the request goes to one of the pod. So what is the service port? This is the node port which I want to use outside. Now we have three replicas, basically three pods. Request is going to any one of the pod. Since I have a multiple replicas, do I have a high availability? Now, will I have a high availability for this application? Now, if you see, I am trying to delete one pod intentionally. I'm trying to delete. Let me delete two pods. Now, do you see the downtime? Do I have any issue? Service is doing its job. What service is doing? Service is trying to make sure it is routing the traffic to the healthy pod. Service is doing its job. Service will make sure it is routing the traffic to the healthy pod. In the background, what controller has done? In the background, again, what controller has done? So who created? Who replicated these two pods again? Who replicated these two pods again? The controller. The controller which is managing these pods. The controller which is managing these pods. Guys, we can scale up, scale down now. kubectl get RC. I can scale up, scale down this controller. kubectl scale RC, my RC name, replication controller, hyphen replicas. I am scaling down. So now how many pods this controller is managing now? I scale down. Now how many pods this controller is managing now? I scale down to 1. Now, will I have a high availability and load balancing? Basically, service will do the load balancing, but service has only one endpoint now. Now, do I have a high availability? If something goes wrong with this pod, I'm deleting the pod intentionally. This pod. Now, is my application is highly available? It was down for some time. It was down for some time. So replication controller has identified that the expected number of replicas are not there. So it has recreated, but it was down for some time. Service is there, but since service is not able to find any pods, will it able to route? Service is there, but service is not able to find any pod with that given selector. So if there is no pod, there is no endpoint, will it able to route? So this is how you can use controllers, replication controller. So replication controller will manage the pods. If required, you can scale up, scale down. Now expected to, current to, ready to. Right? You can scale up, scale down using command also, or you can update your YML. And you can update your YML and apply. Now replicas as 3 or replicas as 4 or 3. Now I can update using YML, kubectl apply -f, something like this, RC. Now 3 replicas. So as of now, we are trying to scale. What type of scaling we are doing as of now? Manual. Guys, scaling will be part of Kubernetes itself, not outside. But as of now, we are doing manual scaling. Only manual scaling as of now. As I told, we can do the auto scaling in Kubernetes. We can do the auto scaling in Kubernetes. So how to do the auto scaling, we will discuss in the subsequent classes. Based on the load on the pod, based on the CPU utilization, based on the memory utilization, you can scale up, scale down the pods. That we will discuss in subsequent classes. Now we are doing a manual scaling. We can scale up, scale down. Right? So this is replication controller. Now if you see the pod names, in my manifest file I have given pod name like this, but is it using that name? While creating a replication controller, I have given pod name as this, but is it using that name? Request scaling is not there. Based on the request, number of requests, you cannot scale in Kubernetes. Only based on the CPU and memory utilization, you can scale up, scale down. So basically, if you have a more number of requests, obviously you will be having a lot of CPU utilization and memory utilization. So if you see the name of the controller, basically the name of the pods, if you see your replication controller name. So these 3 pods are managed by this replication controller. Replication controller name, some unique alphanumeric character. So this is the pod name. Why it is not taking this pod? Why it is not taking this name? Any idea? Why it is not taking this name? When we are using replication controller, why this is not using as a pod name? How is it appending? That is how Kubernetes is working, right? That is how Kubernetes is taking. Why it is not taking this name? Any idea? Because of number of replicas, right? Can I have a 2 pods with same name? Now I am saying 3 replicas. Can I have a 2 pods or 3 pods with same name? So that's why it is not taking this name. It is creating replication controller name, some random alphanumeric character. Our replication controller name with some alphanumeric character. So this is how replication controller is working. You can scale up, scale down. Now if I want to delete all these things, If I want to delete all these things, what I have to delete, guys? Permanently, if I have to delete all these things, I have to delete a replication controller. So tomorrow we'll try to continue with other, like what is replica set, what is deployment, what is daemon set, right? Tomorrow we'll continue. Today, just try to create a replication controller, try to scale up, scale down, and try to create a service, right? As I told yesterday itself, service is just a logical concept, but who is doing the actual work? Yesterday, I think last week itself, I have discussed what is service, right? Service is a logical concept, but the real work is done by the kube proxy. Service is just a logical concept in the Kubernetes, right? Once you create a service, the kube proxy will have all the required routing rules, network routing, network proxy. You create a service, in the background, the kube proxy will have a routing rules. Like for this service, what are the IP address of your pods? What is the port it has to route? You are creating a service in the background. Service is updating the proxy rules in the kube proxy. So tomorrow we'll continue with this. Today, try to create a replication controller, try to scale up, scale down, and try to create a service and try to access internally and externally. We'll continue tomorrow. Thank you.